done some stuff on this already. We've already in our openers. We've always had, in this case here, if you take a look at their openers, we already had a piecewise definition. This is a piecewise definition here. Okay. This right here is a piecewise definition. We are going to write that piecewise definition. We're going to learn how to write it right now using in our notes. So if you want to have a list of things we do, all right. So back to what we were doing, because we were discussing this, and I got. Guys, your cell phones are not in your pockets. They're stored away all day long. Okay? They're not to be out. I'm going to start collecting them. Okay? It is not. You don't carry them around, and you don't grab them when you go to the bathroom. You're supposed to do that either. Okay? Guys, I'm tired of it. I stand right here and I see people all day long, okay, violating the rules and not complying with what's supposed to be state law. All right? It's irritating, and it's one of my pet peeves. All right? I'll relax. But if I sit there and go like 10 minutes of just preaching about it every single day, you're going to get tired of me saying it. So just put them up. All right. There you go. So we're going to write our piecewise definition. So I'm going to make a list over here so you guys can see it. So number one, first thing we're going to do is we're going to write our piecewise statement. Okay? So this is step one. So the write our piecewise statement, as you saw just a few minutes ago, it said f of x equals, and you're going to write it squiggly. Okay? And so you're going to have two pieces in your piecewise because this is an absolute value. We have a positive side and a negative side. So if I'm looking at this, this is the piecewise. Only what's inside the absolute value is our piecewise part. I don't care about the 2 and the negative 3. It has no play in this. So inside here, remember that inside here can be a positive, right? Or it can be what? Are those exactly the same thing? Okay, those are the same thing. So when we're writing our definition, we can say, hey, it's positive, and then we say, hey, it's also negative. Okay? That is what we're doing here. Now, if I'm talking about on the positive side, and Addison can answer this question, positive numbers, how would you describe that to somebody, Addison? How would you describe positive numbers? They're not negative. Correct. Can you give it a little bit more description if you're trying to explain it to somebody what positive numbers are? There you go. I like that. They are, we would use the word greater, okay? Above is the same, but mathematically we always say greater, okay? So we're going to say greater than 0. So I am saying in this case here, these are my positive numbers, all right? It's the positive side. So we're going to take x minus 1, and we're going to make it greater than 0. Okay, does that make sense? So the numbers are greater than 0. So let's go ahead and solve that. Well, how would you solve that? What would make it? So I would add 1 to both sides, right? And so in this case, x would be greater than 1. So, not to pick on you, Addison, but where would your negative numbers be if their positive numbers are greater than 1? Less than 1. If my positive numbers are greater than 1, then my less than numbers, or my negative numbers, would be less than 1. Okay? So what would 1 be in this case? Plug in 1, what would you get? What's 1 minus 1, guys? It would be 0. 1 is 0 in this case. All I've done here is take, guys, I'm taking this absolute value. I'm moving the number line to the right one. That's all I'm doing. I'm moving it to the right one is what it is. That's what's happening here. Okay, we're doing a transformation of right one. So that's my transformation. The transformation right or left is going to be where your new vertex is. This is where the vertex is. To the right of the vertex is the positive numbers. To the left of the vertex is the negative numbers. Now, in this case here, I have this going on right now. If I graph this, this is what it would look like. So how do I fill in that circle? Because that's an open circle for that one and an open circle for that one. You need a closed circle. How do you get a closed circle? Equal to. Which one do you want equal to? Do we do both of them? Can't do both of them. It's a function. So we have to pick one of them. Now, you can choose either one. I don't care. I will always pick the top one. Okay? The top one just made it greater than or equal to 0. Okay? And that will be easy. So that's your piecewise statement. That's how you write that. Okay? So let's break tradition here. Instead of solving, let's, on the back of your notes, you can flip them over. We're going to try a couple and write our piecewise statements for these. Okay? So I'm going to ask, we'll make these fun in some way. Mary Beth, how many siblings do you have? Huh? 1? All right, so we'll just make it X then. 1X. All right, we're going to subtract how many dogs you have, Kate. 3. All right, so we're going to write the piecewise statement for that. Okay? I'm going to keep it, I'll keep it simple, stupid for you. So this is how I teach those who don't really understand the process. I mean, don't understand the understanding of it. Okay? This is the way I teach those who say, I just want to know how to, just let me read it out. I'm going to write X minus 3 here, X minus 3 here, and X minus 3 here. I'm going to write it down how many times? 3 times. I can even write it here. I can make it a 4th time if I wanted to. Now, so this is real basic for a lot of students. If I was going to make it really, really basic for you and keep it really simple, stupid, you've got it 4 times. This one is negative. Positive numbers are what? Greater than or equal to 0. And negative numbers are? That's the piecewise statement. That's simple, stupid. Okay? That would be suffice. If you did that right there, I would give you your points. Now, what I want is you to move what? I want you to add the 3, and I want you to make that positive 3. X is greater than or equal to positive 3. Which means if the positive numbers are to the right of 3, then it means the other one has to be to the left of 3. Okay? So you don't really need this one, if that makes sense. Because if you got that one, you have this one. That's just not the way I do it. All right? This is the way I teach it. If you don't really understand what's going on, I say, all right, here you go. But I want you to understand what's going on. And so the way I do this is, remember we talked about the positive side, the negative side of the absolute value. Remember these numbers can be positive or negative inside. So these numbers are positive. So then I go ahead and, hey, solve it. So you add it over, so X is greater than or equal to 3. Which means that the other one has to go the other direction. And that's generally where I just say, hey, this is where your understanding is. But if you want a little simple, it's X minus 3, X minus 3, X minus 3, 4 times. Greater than or equal to, less than or equal to. Boom, you're done. Okay? All right, so let's do another one. Knox, do you have brothers and sisters? Yeah. Come in. 2. 2. So what about 2X? How many animals do you have at your house, Mr. Morlock? 2? All right, so we'll do minus 2. No, we'll do plus 2. All right, so let's write the piecewise for that one. So I'll give you a second to write that down. this is worth at least 1 to 2 points on any quiz or test. And it is on every single lesson, basically, from factoring on. So absolute values will be happening throughout the year, and anytime we see one, we have to write a piecewise statement. So get comfortable with it. All right, so 2x plus 2, you got that? Negative 2x plus 2, you got that? Comma. Sometimes you'll see teachers write the word if here. It may be in your Math Excel written as if. It's this if this happens. Okay? I just use a comma. I think you kind of understand. All right, now, in this one here, you're going to take the 2x plus 2, and you're going to be what? Great. So subtract the 2 in my head, divide by 2, I get x is greater than or equal to -1. Now, I went ahead and did in my head. You guys, go ahead and subtract and divide by 2, because I have a lot of people try to do it in their head to get it wrong. Just do the simple math in that. Okay? I'll do it for you. I'll slow it down. Maybe I'm moving too fast. I just don't want you guys to crash out, okay? So x is greater than or equal to -1, which means the other one must be less than -1. These numbers should be exactly the same. Okay? Just the inequality difference. Feel good about it now? Practice it on every single problem, because it has to be. That is step 1. All right? It is step 1. Go back to this problem then. All right, step 1, piecewise. You got it done. You've earned your points for that. All right, step 2, as I said yesterday, is isolate. Okay? So step 2 is isolate, which means that I need this inside here. You never touch the absolute value. You do not distribute the 2 in. You do not add anything in. Whatever that x minus 1 stays the x minus 1. Okay? So it does not change anything. You have to remove everything else. Now, do you guys know what this thing here? What's that called? PEMDAS. Please excuse my dumb blank sister, right? So in this one here, we do the other one. When we're solving, we do, anybody know what this one's called? Segment. All right? If you had Miss Love, she's called it segment. All right? In this case here, you're always going to do what first? Add, subtract first. So I have a plus 3. I have to minus that 3. That minus 3, I've got to add 3 to both sides. Okay? So I do the add, subtract first. Then I have 2. That's the value of x minus 1 is equal to 2x plus 6. What would be the next thing that we have to do? Multiplication or division. What's going on? Division. We're undoing it. So if I am multiplying, the undo of multiplication is divide. So we're going to divide by 2 to every single term. To everything. That will give you just an x minus 1 is equal to x plus 3. Okay? All right, it's isolated. What is step 3? This is, I'm just going to put 2 equation equations. One that's going to be positive and one's going to be negative. Okay? We're going to write 2 equations. So in this one here, if I'm doing 2 equations, I'm just going to set it like this so you can see it. I'm just going to put a POS on this side and a NEG on this side. That means positive, not piece of, all right? So, make sure, okay? You understand what it is. So when we get this done, we're going to write two equations. Guys, positive means, guys, we're back to our piecewise again. We have a positive section and a negative section. So I'm going to go over x minus 1 over here. I'm going to put negative x minus 1 in parentheses over here. Now I'm setting it equal. Remember, I had two parts. Either that can be positive or that can be negative. That's the understanding of this, okay? And then you're going to set it equal to x plus 3, and you're going to have equals x plus 3. What do you think step 4? Actually, we can make this all into step. We can make it all into step 3. Write the two equations, and then what we do, solve them. So we'll just make that all one. We'll make our steps really, really short. So we're going to write the two equations, a positive and negative equation, and you're going to solve them, okay? That is going to be step 3. So we're not done with step 3 yet. So I'm going to give you a second. Go ahead and solve those two equations. Those are fairly basic equations. Those are locked in. I like it.
No,
Probably going to be some work. February. It'll be in February. This lock is. I know her as church. All right, so here, if I subtract x, if we subtract x right here and right here, we get negative 1 is equal to 3. You could have moved the 2 over, and you could have had 0 is equal to 2. Either way, what's going on? No solution. So in this case here, that's not valid, so this would be no solution on this side. Interesting. All right, so let's see what happens on this side over here. Now, okay, it's the number one mistake that is made in absolute values when you know everything, when you know your piecewise, and you know how to set up your two equations, and you're really good with it, and you're very confident. The number one mistake that is made is not distributing here. Okay? Mistakes that are made, if you're not confident, you've been practicing, yeah, this will be hard for you if you're not practicing. Okay? And so that's not what I'm talking about, because that is a major mistake a lot of people have, is not doing piecewise, and then they write only one equation. If they really don't know what they're doing, they'll just solve it as a positive side, they'll not do the negative side. They really don't understand or not paying attention. But I don't think that's going to be any of you guys' mistakes. But this mistake is probably one that I will see out of somebody in here, okay, is that when you distribute this negative, that makes that a negative x plus 1, okay? That is the number one mistake. And I want to point it out because I've been teaching this for, I don't know, almost 2 decades now. And so this mistake has happened a lot, okay? And I'm trying to nip it in the bud now, all right? As Barney Fife would say. All right. Nip it in the bud. All right. So that was a horrible Barney Fife. So Andy Griffith, you ever seen Andy Griffith? With Opie Taylor, old black and white, 1963. And then in the last seasons, they were in color. Amazon Prime. Kind of watch it. It's pretty cool. Has a whole bunch of episodes, and there's 8 episodes where he's smoking, which is interesting. But it was before the no smoking thing was happening, which is kind of crazy. But, all right. So add the x to both sides. I'm going to add it over here. I get 2x. I'm going to subtract 3 from this side over here. I'm going to get negative 2. Divide by 2. X is equal to negative 1. Everybody got that? Now, step 4. Check. No domain. Hold on a second. Whew. I got congested this morning, so I think my COVID is just kicking back. It's like
It went away for COVID.
no, it's a wave for me. You know, I have to understand with COVID, if I didn't have my vaccines, I probably would have been in the hospital a little bit. Like, I get sick. I really get sick. So what happens there is I've been vaccinated every single time with Moderna and I started with Pfizer, but then I got it. So I did Moderna. I hadn't got COVID since until this year because they didn't have the vaccine out. So I caught it because you guys gave it. So.
But you still came to school, though.
Correct.
Do you know that you had COVID, or you just assume?
I'm assuming. Because it was the razor blades, and if you had your razor blade throat, that was COVID. Now you get tested on it. Well, it's not deadly anymore. When you had it first time, when you had all these people who were unvaccinated
It's like coming
going
to
around.
the flu.
No, not the same. The flu I had, if I have the flu, I have high temperatures, right? You have fever. I didn't fever with this COVID at all. So, and I caught it over the weekend. Like I had it on Friday. When I left here, I knew I already felt that. So I had Saturday and Sunday.
Say that you had a man
I'm
cold?
fine. No, you can call it a man cold.
Do you know what a man cold is?
I have no idea, but it's okay. So back to this. Check with your domain using your piecewise. Okay, so we're going to use our piecewise in this. So you would take this, which was x is equal to negative 1. You've got to check your answer. This is the negative side, so we take the negative 1 and we plug it in here. Is negative 1 less than 1? You check it off. There it is. So what happened over here is the question. Why did that fail on that side? Well, let's do, we have this beautiful graph over here. And so we're going to use this graph. On your tests and your quizzes, you will have a graph most of the time with these absolute value equations. You can graph them to test your answer. I want to see an algebraic solve, so I want to see your algebraic proof, but you can use the graph to help you make sure you got the right answer. Now, looking at this is your equal sign, right? So we're trying to figure out when is this equal to this, correct? What is that? Anybody know what that is? Graphically. It's a line. Where would you start that line? 0, 3, right here. What's your slope? All right, so I'm going to go ahead and graph that line. All right, so what is this over here? What is boxed in purple? Your absolute value V, correct. So what are your transformations on your V? Right, 1, down, 3. I love it. What else we got? The 2 is a vertical stretch of 2. Somebody knows they're going to make 100 on the quiz tomorrow, all right? Because we know your transformations. Guys, we do have a quiz over transformations tomorrow. So this happens, the parent function, and this one happens to be V, right? So we're going right 1, down 3. I'll just go ahead and draw and right 1. I'll use this little mint green, light mint green, like you would have at this ice cream shops. and down 3. It's never a real strong green.
Oh, ours is. Did you see it?
No, I did not. Is that the pistachio though? Isn't it
They're all
pistachio
the
usually?
We
Oh,
had it early today.
did they? Because everybody ate it and loved it?
Yeah.
I hate that stuff. Ugh. All right. So once you have this, once you have your right and down, Katie wouldn't know. She doesn't know. So she doesn't know if you're in or out. She doesn't know the flavors are in or out now. So this right here, once you have the right one and down 3 is what's next? Parent function. The parent function is a V. Absolute value. Anybody know the points for the absolute value graph? I'll do it in a nice red. Oh no, I'll do it in blue. What happens when you plug in 0 into that equation? It's just the 0. What happens when you plug in 1 into that equation? 1. 2 would be 2. 3 would be 3. 4 would be 4, right? The absolute value of 5 would be 5, correct? What happens if you put a negative 1 in? That's right, 1. What, how about negative 2? Negative 3, negative 4, negative 5. So those are also positive. Does that make sense? So I draw the V, which, well, actually, no, forget that. Don't draw the V yet. That was a parent function because what I forget to do. My other transformation, I'll do it purple. My other transformation is a vertical stretch of 2. So I got to double the distance here of these by 2. So that one is still there. This one goes up 2. This one's 2, now it's 4. This one is 3, now 6. This one is now 8. And then you have the same points over here on this side. You might know what slope it's following. So a lot of people think that this is slope. That says, oh, it's got a slope of 2. It's going up 2 over 1. Notice all the transformations in the last week. Have we done any absolute values?
Yeah.
Did we do any absolute value transformation? We did not. On my sheet, I don't have them. We used to, years ago, we would start with absolute values. Let's transform them. And we would transform them, and then you guys got stuck on thinking, oh, that's just a slope. And then we changed that to a parabola, or we changed that to a cubic or a square root graph. You guys lost your mind because you're thinking, oh, it's a slope. It's not a slope. Okay? So because the V, the blue graph right here, is so symmetrical, here, it's on the y equals x line and the y equals negative x line. Because those pieces are there, it makes it really, really hard to show a stretch or a compression. So we remove that, and everybody's transformations change so drastically. And then we have to re-teach you again. So we teach you absolute value transformations, and then we have to relearn transformations again because you guys didn't know you weren't doing it. So that's how you would do that problem. So take a look. What's going on? What's happening on the positive side? What's going on with that right there and that right there? They're parallel, which means they'll what? Never intersect. That is why we get no solution, because they don't ever intersect. Okay? It only intersects on the negative part, which is, you can tell right there it is. Right there at -1. Okay? So there is going to be, this is a tested or a quizzed item. So this can happen within your work. There will be an instance when you have like 3 is equal to 3, maybe in your notes in your homework. What happens if you get 3 equals 3? It's the same line. So this is what it would look like. It would be right here. And so you would still get an answer over here where the vertex is. And that one would be 3 equals 3, which would be this. Now, you would have to write your answer solution set, that line, plus everything to the right. So these would not exist, if that makes sense, graphically. Guess what? We're not going to test you on that, right? So this scenario here, when you get 3 equals 3, will not occur unless it's in your homework or in your notes. On a quiz or a test, it's going to be different scenario. Okay? Does it make sense? It's good to stretch your brain and think about it when you get to those problems. All right, now, example number 2. All right, example number 2. All right, what's step 1? All right, let's go. Right piecewise. I'll help you out. Remember, it is only going to be what? X plus 3. Check your piecewise. See if your piecewise is the same as my piecewise. Now, I try to write it very small over off to one side. You don't want this to take up most of your paper because you will need that space for the actual solve of the equation, just so you guys know. Okay, so I know some of you guys get your like really fancy and start writing really pretty fonts that you guys have. Okay, but try to make it a little bit smaller. See, I think I can do this. Let's see. Oh, no, it won't let me. It's not gonna let me. It's not gonna let me pick it. I was gonna try to select it and I can shrink it. Because this is an image, you go back to it. All right. What is step 2? Isolate. So we're going to isolate the absolute value. So what would you do first? Yeah, we got to do, remember, we're doing what? SADMAP, right? SADMAP. So we got to add or subtract first. So which one? Subtract the 1. Now, okay, let me go ahead. I'm gonna rewrite this problem so you can see it in a little bit different light. This happens. I'm going to go ahead and give you an example of what might happen in your homework. So this plus 1 right here is in front. I am still going to subtract 1 from this side. I'm going to subtract 1 from that side. Okay? I want you to see that. All right? This happens a lot of times. I have students who want to do what with the 1 and the 1/3, guys? What would you want to do? Some people want to do. They like to add those suckers together. Can't do that. Okay? This one here is being added. That one's being multiplied. It is completely different. Okay? Can't do it. Not allowed. So try to get that out of your head right now and make sure you get that correct. All right. So we're subtracting 1, so I'm going to get 1/3 as the value of x plus 3. Equals 1/6 plus 2. What's the next thing? Yeah, we want to do the opposite of the multiplication. Of 1/3, which is multiplying by 3. So multiply by 3 to everything. So I get after value of x plus 3 equals 1/2 x plus 6. Okay, so I'm going to erase this stuff here. We'll move this up here. So I have a little bit more room up here. So we're near our piecewise. All right, now, so you can visually see it. You know what the next step is? Once we have it isolated, two equations. So we go back to our piecewise. We take a look. I got to put an x plus 3 on this side and a negative x plus. So we have that side. Set them equal, and then write the 1/2 x plus 6 on this side, and the 1/2 x plus 6 on this side. See how it flows? It's a nice flow. In this case, I'm talking about the positive, I'm talking about the negative, very similar to our piecewise. It flows well. All right, now, solve the equations. Weekly, what would you do? What would you do to solve this? Subtract the 3. Subtract the 3, I get x is equal to 1/2 x plus 3. Now what? All right, so subtracting 1/2 x. So what's that give me? Oh, I like it. It was easy to kind of work with, wasn't it? Ooh, I like it. Multiply by 2. So x is equal to 6. Good job. Is there another way? Is there a way to avoid the fraction? What do you think, Colton?
I don't know. I added the 1/2 x. Got like 2x plus 3 equals 6.
Okay. You still got 6? Did anybody try to avoid the fraction? Did everybody kind of deal with it? All right, let me show you. This is a trick. Brianna liked this one in the morning. She multiplied everything by 2. And that gave her 2x plus 6 equals x plus 12. And then when she subtracted the x and subtracted the 6, she got x is equal to 6. Okay, so that's one way you could avoid the fraction if you choose to. Okay, I just wanted to show that to you because I thought that was a neat way to solve in it. Okay, so you don't all have to solve the same way. Makes sense. All right, look at this one here. How would you solve that one? Did you multiply by 2? And when I multiply by 2, I do this one, and
Well, I distribute.
oh, you made that a negative
I just wrote it.
x minus 3?
Yeah.
Oh, you wrote it down like that rather than like that. So you distributed in your head before you got there. I would try to tend to tell you go ahead and write that down, and don't forget to write it down so that you don't forget, because sometimes you will distribute in your head incorrectly and you won't follow your work. Okay? This is showing me right now, it's showing me that you know that's positive inside and you're showing me negative inside. So I would rather you leave it undistributed, if that makes sense. And she went ahead and multiplied these by 2, got negative 2x minus 6 equals x plus 12. Now, you can do this in 2 steps. You can do it in 1 step. The double step. Okay, what would you do? If you're working with her work. All right, so you would add the 6 here and subtract x. That's what I'm talking about, a double move. Doing it at the same exact time, and so it ends up being that. Okay? Really quick, right? And then divide by. And x is equal to. All right, it's easy, easy peasy. We can go ahead and check our answers. Slide it up just slightly so you can see piecewise. The negative, that's a negative 6. That negative 6 is it less than negative 3? Yes, it is. Is 6 greater than negative 3? Yes, it is. So those are both answers. Okay. So let's see if we can graph these. Look at the graph of that side. What is that? 1, 6x plus 3. That is going to be a graph of a line starting at 0, 3 in our SOAPs. 1, 6. So we get this really flat line right here. Moved up 3 units. Guys, it's really moving this line. Remember, we're moving the line up 3. It actually, a line is just 1 up 1 over 1, and then we have a compression of 6 on it, if you want to think of it that way. So here we'd be at 6, 6, we're compressing it down to 1, 6. That is the way a line actually is when it is in slope-intercept form or point-slope form. It is just transformation. All right, take a look at transformations on our absolute value graph. This is a V again over here. And so what's our transformation for this one? Depression of 1/3. Left 3 and up 1. So again, I'll try to use the mint green here. And so we'll go left 3, up 1. Parent function is a V. And we're taking those points and we're compressing. What are good numbers to compress on this? 3, 3, and 3, 6, and 9, right? Would that make sense? The distance So what I'm trying to say here is it's better to do this one right here at 3, because if we're 3 up, then we're 1/3. If we are 6 away, 9 would be here. Again, as I said, absolute value is the only one of the transformations that you can say that 1/3 is your slope. It has it positive and it has it negative. So it would be positive this way, and then we would go up and over on this side negative. So as you can tell, here is the V, the X equals 6 right there, the X is equal to -6 right there. It's really kind of evident. The positive 6 is on the positive side, right? It is intersecting on the positive part of the absolute value. The -6 right here is on the negative side. That is where that is intersecting. Okay? So it kind of puts, like I said, this really puts the absolute value into motion for you guys. I know you guys work with them algebra 1, you're going, oh, whatever, it's just a V. After that, you know, like other than that, there is a lot of math involved in here. Okay? And you will use it throughout all the way up into calculus. Okay? The piecewise definitions are really important trig and pre-calc. Calculus, probably not so often, but they do use it at times. And so you have to know it. All right? This definition right here is a must. You have to know it. All right? And if you have the understanding of where it comes from, then you can remember it. Okay? If you're just saying, it's just a trick, I don't always remember the trick. Okay? Let's you practice some of this. All right, we're going to do one more. Example number 3. There are like 6, 7 examples in here, so we're going to try to do 3, 4, but we're going to stick with just doing 3. Yeah. You see my BB 6-7 yesterday, right?
Even before you miss some shots.
Yeah, he did, didn't he? He got chopped occasionally. I always thought that Jordan is tripping with that. He's legend. He's like LeBron's. Yeah. All right. Let's step 1. Piecewise. Guys, go ahead and try this one on your own. I will float around and make sure you have any need support. I will help you. So you're going to do your piecewise. You got to isolate. You know your first steps. And then you got to write 2 equations and solve.
know the definition of Wednesday? Still not right. The definition of Wednesday is still not right.
Over here, we're going to do x minus 1 is greater than or equal to 0. So when I add 1, I get x is greater than. And then on this one, it will just be the flip of that equal, but no equal sign. Make sense? Then you want to isolate. So we're going to isolate this. So how do we get rid of that 3? So we're going to divide that. When we divide, minus 1, right? And here, I know it's a positive. And we have minus 1/3. Now, what's this isolated? Step 3 is right. We want to write 2 equations. Okay? So we want a positive equation and a negative equation. So we're separate. That's your positive. That's your negative. You set that there. You set that one. Yeah. Okay? And then we're going to solve this. So this one's got a 3 and 5. So we're going to multiply. So we're going to multiply 3 on everything. We get 3x 3 equals 3x minus 1. Next negative. This one, you get plus 1. And then you can multiply by 2. Now what happens? You're free to make the truth. But I look it up. Your two solutions, your two solutions. Hey, you good? Second. Yeah. What's so good? Smashed it. Good. I got it. Okay, sorry.
Hey, what's up?
So is 4-6. 4-6, 6-6 is 1. You got a question?
Do you want us to do number 4?
You can start number 4. I'm going to go over number 3. Which we would never have an inside one on. So we like I said, we had problems when we tried to transformations. We couldn't do an ROI on it. Like parabola, you don't do. You've never seen ROI on a parabola, really. I mean, what happened? It's the same. So it was hard for students to get the transformations figured out by doing that. All right. So this one right here, guys. Piecewise. Really, really simple. Remember, you take x minus 1, negative x minus 1. You're going to say here, x minus 1 is greater than or equal to 0, which is x is greater than or equal to 1. Flip the inequality. There it is. That's that simple. Divide by a negative 3. This is where you guys kind of messed up. Guys, you're going to divide everything by negative 3. This x minus 1 stays here. That will make that a positive x minus 1/3. Now, that's when you write into 2 equations, step 3, and solve them. So x minus 1 is equal to a negative. And then I have a negative x minus 1 here. And they're going to equal the same thing, which is just x minus 1/3. X minus 1/3. Now, I'm just going to go here. I know some of you guys multiplied this by 3 to get rid of your fraction. But I'm noticing the x's are the same here. See that, Kate? I know that. What happens when I subtract x from both sides? They go away. So that side has no solution. Okay? You could have multiplied by 3. You're still going to get 3 and negative 3. It's going to go away. It doesn't turn into 0. It's gone. Okay? Boom. Disappeared. This side, I get negative x plus 1 equals x minus 1/3. Now, a lot of you guys did multiply by 3 to this to get rid of that fraction because they didn't want to work with it. Great. Negative 3x plus 3 equals 3x minus 1. Check to see if your distributive property, when you distribute the 3, that you got this line. If you made a mistake here, okay? Because you should have got 2/3 down here. Because I'm going to add the 3x, right? I'm going to get 6. I'm going to add the 1. That's going to give me 4. I'm going to divide by 6. That is going to give me 4/6, which is 2/3.
You multiply by
Here, on that one,
like when you're repeating, it's like
I mean, if you want to make that 3x minus 3 equals -3 plus 1, you could. It would be like, I don't know why we multiply by a negative. Because I'm solving, right? I'm solving so the x go either direction. If you wanted to, I mean, you can. I don't know. I wouldn't see the point in multiplying by a -3, other than you're making that front number positive. If it helps you and make you more comfortable cold, then it's fine. Right? It's like wearing a hoodie. If you want to wear a hoodie, that makes you feel more comfortable, right? You wear a hoodie. Right? All right, so let's graph it. So this one here, you guys know how to graph that, +1, and then you have a slope that's -3, +3, and so down 3, so you get this line. So you asked the question, some of you guys asked the question, what's your transformations on this one? ROX, top front. Vertical compression of 1/3. No, take it back. You didn't lie to me. It's a vertical stretch of 3, correct. And I'm going right 1. All right, so this one I'll use the strawberry pink ice cream that you would get. So right 1. They don't have the deep reds sometimes in those ice cream shops. It'll look like that. Plot your points. But what happens to your points? ROX, which means you're going to flip them down. And then we're going to stretch those points by 3. Which makes sense as it's going to be here. That one's going to be here. And as you can tell, it's going to go over 1, down 3 every single time. So you're going to get. So right there, that's where X right there is at 2/3. And that point right there, it's supposed to be more steep. I messed that up. That's more steep. In this case here, you get the 2/3 right there. You get the kind of a understanding there. And then the green line is parallel. So that's the positive side is parallel. So the side on the right. Questions? All right. So that's how you do absolute values. Now we'll finish the other 4 tomorrow. So we had a few minutes. We can grab our notes out from yesterday, the day 3. Day 3. Looking at this one.
I know. That's nice.
I don't know. So we're looking for this section right here. Down here, this factoring section. Block A, we went over it today. I wasn't Blake. I didn't go over with Blake. I went with Block A. All right? Block A. So really for Block AA, Aaron. Well, anyway, this one right here, I did it in C block as well. We talked about this yesterday. So we are going to do transformations, and we'll just do it here in a minute. Good practice. If you want practice for the quiz, you would finish part A and B on this, okay? You would do these separately. All right? That would be good work. Because to quiz tomorrow will not have factoring on it, all right? So you're not going to have any factoring to worry about on the quiz on tomorrow. It will be on the test next Friday. Now, this one right here, If you need to, you can look at Canvas next week. There is a quiz on Tuesday over absolute values, and there is a test on Friday over the whole unit. Okay? I'll just show you. This is the quiz. I mean, this is next week mapped out. Okay? So we have time quizzes every single day. The times quizzes are on squares and cubes every single day next week. They are counting 15 points apiece. Okay? That is 45 points. That is worth 3 quizzes. And it's just memorizing squares and cubes. That's how important it is. And so if your grade is suffering right now, you have a great opportunity. This weekend, I pulled the flashcards out. I'd make sure I know my squares and my cubes. Now, the only way it will be going is if you have like 196. You would have like 144, 289. Then you will write down these pieces here, or 64. So anybody know 289? Oh, I guess you guys need to get your flashcards out. That's 17 squared. 144. That's 12 squared. 196. That's 14 squared. You got 64. What's that? That's 8 squared, or 4 cubed. So you would have to write down one of those two. I am expecting the little numbers here. These are what we call exponents. Okay? So we will take, and you have to write the exponents down. It is only going from the answers to your squares, because that's what we're looking for when we're factoring. All right? So there are 5 quizzes, 1, 2, 3, 4, 5, but I'm only counting 15 points apiece, and you're only getting 45. So what's happening to the other 2? Well, in a way, they're practice, because I'm taking the best of what? The best of 3. So I'm going to take your top 3. So if Aubrey comes in and she scores a perfect score, a perfect score, a perfect score, then she can just go ahead and crap on those, right? But I'm expecting her to go ahead and do them anyway. So everybody will do it, right? Well, actually, maybe not. Take that back, because it takes less grading. So if you make perfect scores on these, then I'm going to exempt you from these. Okay? We'll do that. Does that make sense? You do have a quiz on absolute value on Tuesday, and there's a test here. If you wonder what's on the test, you can click right there on that test, and it has all the learning targets that we're doing. Okay? It is all mapped out here. The thing is, some people go like, well, I'm going to be absent tomorrow. What are you going to do? It's right there. And I even put class recordings up every single day. So you can click down here and watch the recording from the previous day. Hopefully I got it posted. Okay? Sometimes I record it, and then it takes a little bit of time to process it and publish it. Okay? So there's no excuse for the finding work. Your notes are there. Remember, your homework is here. You're wondering what the answers look like. Go down here. Now you got to show me your proof that you did. All right. We've already caught kids using AI in here. All right. Not in my class yet, but you better not be using AI to do your homework. Okay. And so there's consequences. All right. So enough on that. Let's go back to this here. All right. How to factor, guys. All we're going to do here is, if you are factoring within transformations, there will always be a parentheses on the left side. You're going to separate the 2 and the x with a set of parentheses, or whatever the number is with the x. There will always be a double parentheses at the end. And then you got to tell me what the number would be here that would make that happen. If you were distributing back in, you multiply that back together, what would happen? You would get 1. If I am multiplying this way, what's happening when you're going this way? If I multiply this direction, you would be what? Going this way. You would be dividing. So this is multiplication this way. We are dividing this way. So if you want to think of that, take that 2 and divide these by 2. That will give you the same answer. Okay? So, again, I'm separating the 4 and the x. Double parentheses here. The sign's still negative. I need the parentheses between the x and the 4. And what number would go here in order to make that happen? 2. So you're going to take the 4, you're going to divide each of those by 4. So it is 2. You can mental map that and say, what number times that gives me that. Okay? Oh, I got a half. Oh, this one's crazy. So, people get kind of freaked out over the fraction ones, but guys, you're almost as easy, or maybe not be easier, than the multiplication ones. As I said, here we are multiplying this way, which means we would be dividing this way. Well, this is kind of like dividing this way. If I'm multiplying by a half, I'm dividing, which means I'm multiplying this way. So that number has to be 11. A 6. I am multiplying by 2 to each of those. I'm asking you, how many halves do I have in 3 is the question you're asking. When I'm dividing things up. I have 3 whole pizzas there. I'm cutting up into halves. How many halves are in that? 6 halves. Okay? That is what division is. Okay? So, this one here, I have a negative sign. You still have to keep the negative and the x separated. Because when I multiply by a negative here and here, what happened to your sign? It switches. So you want to say, oh, it's going left too, and I have an ROY. You're wrong, because you're going ROY, but you're going right too. All right? So you have to factor first. So that is the key in these, is factoring first. So, all right, let's take a look at this one. Ooh, I got a negative 1/2 at x, parentheses, parentheses. I'll give you a second. Go ahead and try those next 4 out. No, sorry. That X is in the wrong spot. Thank you. She was correct. She corrected me. While you are doing that, we're going to pull out. We started with that. Yeah. We're busting it. Make sense? We want to factor it because your transformations, your transformations there, if you look at number 2, you think, oh, I'm going right 8. You're not going right 8. You're going right 2. Make sense? I have a horizontal compression. So you're going to lose a point. Factoring is a point. Okay? And it will mess up the rest of the graph. So we need to make sure we know what we're doing.
Yes. That I told Miss Lee that I literally was like, I couldn't do this.
Boy, you couldn't do that?
I love her.
She's awesome. She is not here.
I'm aware.
She's back with us.
I know. She
went there every weekend.
Yeah, did you not know that? I knew she was. She went there every single weekend and she had to finish school stuff.
She said when she came and took this job, she was going to look at, because her husband had a job here in Duffel, Virginia, or something like that. So she was only going to be here for a 2 to 3 year period. Oh, so this is x what? Minus 10, correct?
Yes.
If you guys get -3, separate the x, you get +9.
Yep.
I get a 1/3, separate the x, and I get something crazy big number, like 24. 1/3 of 24 is 8. And then I take the last one, I get -1/5, separate the x, double parentheses. What number are we here? 2. When I multiply by a negative times a positive, it gives me a negative. That's correct. So the sign is right. And then 1/5 times 2 is 2/5. Okay? So those are your answers. Now, let's take a look at what I just gave you. Find it.
Oh wait, didn't your older used to be near Miss B's? Or-
Yeah. She, Miss, Miss Boyd had my old room. She was in my original room, but Miss Tate and I taught it together. The first couple of years we shared rooms, and so Miss Tate and I shared the same room. She was Miss Hamilton at the time, and then eventually Mr. Mann moved out of room 102, so I went to 102, and then I've been there ever since. I've always been in that corner. No, actually, I started in room 123.
Where's that?
It's right around the corner of the math pod. It's the smallest room. No windows at all. I did feel safe in there. Nobody's going to come find the room. It would have to be a vengeance against me directly. But then it's a fortress in there. So, all right, taking a look at this one right here. We look at that right there. You see that x is not separated. That's the way you would spot this problem. So we cannot say left 4. Okay? If you put left 4 on your paper, you've got it wrong. You have to, in this case here, rewrite this problem. This is a point for factoring. And so you would rewrite it like this. Okay? Since I rewrote it, Murray, do you know your transformations? And what's that one? So is it 2 or is it 1/2? You're talking about age. It's 1/2. Is a half getting smaller or larger? It's compression. Okay? It is inside. It is a horizontal change. Again, I showed these before where you have your H right here. Right? That's your H. The one thing I didn't show over here, and I did show it the last period on these factoring problems, guys, I said parentheses here. This could be a square root symbol. So that first parentheses could be a square root symbol. It could be an absolute value symbol. It could be a parentheses. Those are all like grouping symbols to keep them with inside. Okay? That would be inside. So, pretty simple here. Left 2, down 3. Draw your dotted lines. Then what? Draw your parent function. So once you have that, you're going to draw your parent function, 0, 0, 1, 1, 4, 2. You can use 9. Oh, it is left 2. What are you talking about? Was that what your question mark was, Ellie? You're like, well, what am I doing? All right, there it is. I saw a question mark in your head. I was like, going, what am I must have done something wrong. So I was just hesitating for a second there, waiting to see what you guys would say. All right, 9-3. Then we're going to horizontally compress it, which means we're going to squeeze it in. So that's going to end up being 1.5, 1.5, 1, 1/2, and so it's there. These types of questions will not be on the quiz. They will be in your homework, okay? So if you wanted to practice tonight quiz questions, they would look more like what we did before, okay? On day 1, 2, and 3.
So
Joke?
I'm never telling you a joke again.
Because I know them all.
Yes, right? I'm so proud of you. You didn't know my second one, did you?
It's not.